Assalamu alaikum. We're starting day 5. Our 5th lesson is going to be structured around the topic decimals. Starting from the very basics, going to big structured questions on decimals. Then we'll also be adding 5 new words into our vocab journal, and we'll be trying to memorize the table of 6 all the way from times 1 to times 20. Let's start by taking the biggest bullet first. We'll start with decimals. We want to know how to be able to compare decimals. So anything that's not a whole number, let's say on the number line, anything that's not a whole number, anything that falls in between are called decimals. Let's say 0.5, 0.25, etc., etc., etc. So here we've got 1, 2, 3, 4, 5 decimals that we want to be able to compare with each other, starting from the smallest, getting bigger. So we're going in ascending order. Starting from the smallest to the biggest. Now, if I take a look at the whole numbers, 0, 0, 0, 0, 0, nothing to compare over there, everything's a big 0. Then I look at the 10th place, it's called tenths place, the one after the decimal. I've got a 9 here, I've got an 8 here, I've got a 9, a 9, a 9. So because I have an 8 over here, which is smaller than all the others, which is a 9, I'll say this is the first one. This is the least number out of all. Now I'd go to the second place after the decimal. So we've got like a whole number, decimal, tenth, hundredth. Do you see the TH adds up in the end? Hundredth, thousand, so on. So we're looking at the 10th. We looked at the 10th place. We're looking at the 100th place. You've got a 9 here in the first one. 9. We're not even looking at this because we're done. So we've got a 9, 9, 9, 9. Nothing to compare over there. Everything's equal to each other. Then the one after, I haven't got anything here, which means it's a 0. Over here, I've got a 1, I've got an 8, and I've got a 0. So there's a comparison between the first one and the last one, A and E, because there's a 0 in the 1000th place. Because I haven't got anything after a 0 over here, that means this will be smaller than this one here because I've got an 8 over here. So I'll say this comes position 2, and that is position 3. And then I'm left to compare C and D. I've got a 1 here, and I've got an 8 over here. So naturally this one's smaller, number 4, and that's number 5. So if I want to place them in order, it would be B first, E, A, E, C, and D. That's correct. B, A, E, C, D. Right. Now that we have a bit of we refreshed the idea that we have about decimals, which one's greater, which one's smaller, let's move on to we should be able to add and subtract decimal numbers. So we've got 2 decimal numbers over here that are being added to each other. A common mistake that students do is like 0.905 plus 98.1. That makes no sense at all. It has to be lined up, the decimal under the decimal. So if I've got, let's say, 0.905, then the next one, the decimal here, before that I have an 8 and a 9, 1. Do you see how everything is lined up? That makes no sense. Do you see how everything is lined up? The decimal on the decimal, the ones on top of the ones, tens, tenths, everything's lined up. Now I start adding. So 5 plus nothing gives me a 5, 0 plus nothing gives me a 0, 9 plus 1 gives me a 10. So I put the 0 here and the 1 goes up there. The decimal carries down. 1 plus 0 plus 8 is a 9, and the 9 carries down 9. That's what my final answer is going to be. Now, if you take a look at the next question over here that they're asking you to subtract, guess what? Exactly the same thing. Make sure your decimals are lined up. So if I have 95.0, when I'm subtracting 5 points, the decimal's lined up, right? And then I have an 8 and a 6. I'm subtracting. I have nothing to subtract from over here, which means I need to borrow. If I have nothing, I'll just say that's a 0. That's the same thing as saying it's a 0. I need to borrow. I can't borrow from here, so I'll be borrowing from the 5. I'll borrow from the 5. That cancels down, becomes 4. That becomes a 10. I need to borrow from the 10. That cancels down, becomes a 9. That becomes a 10. 10 take away 6. 10 take away 6 is a 4. 9 take away 8 is a 1. Decimal follows down. 4 take away 5 is not possible. What I can do, I can either do a 94 take away 5 or borrow from the 9. Borrowing from there, 8. That becomes a 14. 14 take away 5 is a 9, and the 8 follows down. So that's my solution. So I know we know how to add and subtract. Just be very careful about lining the decimal on top of the decimal. Yeah, just be very careful about that. Inshallah, we wouldn't need to add and subtract like this. Remember, we said we're not going to be doing any long addition, multiplication, division, subtraction, nothing. But we need to know how it's worked, right? So instead of doing it like on the 21st day, it's good to be doing it while we're doing the topic of decimals. Now that we've got an idea of that, let's move on to multiplying fractions. Now, when you're multiplying fractions, the decimals, we don't care about the decimals. A contrast to what we were doing with addition, subtraction. We do not care about the decimal. I treat it like 0.001. No. I don't care about the decimals. I mean, I can get rid of it. So I'll just say 0001, which is the same thing as saying 1, right? So I'll just rewrite it as 1. So I have a 1 times 31.4. Remember, we said we're going to ignore the decimal. So what I would do is just rewrite it as 314. That gives me 1 times anything is the number itself, so 314. Now, I do need to bring back the decimal. What I do is count the number of places. So I've got 1 decimal place here, 2, 3, 4. So I've got a total of 4 decimal places. What I'm going to do is start from here, 1, 2, 3, that's bad. 2, 3, 4, and that's where the decimal follows. 2, 3, 4 decimal places. There's nothing in here. There's nothing in here, which means I end up writing a 0, and a 0 in the beginning as well. Obviously, it makes no sense saying 0.314. We usually add a 0 in the beginning as well. So that's what my answer is going to be. So I completely ignore the decimal in the beginning. Later on, I count the number of places, decimal places, how many places there are, 4. So I move the decimal backwards. 4. Why am I moving it backwards? Because I ignored them, and the decimal is behind the actual number. So let's try another question. The next one. Again, I'm going to ignore the decimal. 16 times 4, we've done the table of 4, so we know it's a 64. And then I count the number of decimal places, 1, 2, so I've got 2 decimal places here, 3, 4, 5. 3 more decimal places here, so I've got a total of 5. 1, 2, 3, 4, 5. 3, 4, 5. So I move back 5 decimal places. 1, 2, 3, 4, 5. I put the decimal here, naturally 0 comes in the beginning, and 0 fills in the places that are empty as well. So I've got 0.00064, that's my answer. Easy peasy, we don't care about the decimal in multiplication. Next question, again, what do we do? Ignore the zero, correct? Ignore the decimal. 12 times 12, do we know this? I haven't done the table of 12 yet, but I'm hoping you know it. 12 times 12 is a 144. Yeah, 12 times 12 is 144. I count back the decimal places, 1, 2, 3. 3 decimal places, 1, 2, 3 decimal places, and that's the solution, 0.144. The answer. So that's how easy multiplying is with fractions. What are we expecting next? Okay, multiplying and dividing with powers of 10. This is easier than the concept we did previously, the multiplication thing. This one's much easier than that. So imagine we're looking into a very easy thing. It's just a matter of, recalling things that we did, let's say in our childhood or, secondary school or earlier, like grade 4, 5, 6, 7. It's just a matter of recalling things. I'm sure you know of them already. So many times, like while I'm saying, oh my God, okay, yes, I know this. So it's that kind of a thing. And at the same time, even if you do know them already, just try and keep an attentive ear to what I'm saying because, inshallah would come in handy. Because when we're doing tougher problems next week, the week after, we don't want to be discussing these minute things. Anyhow, if it's still a problem, you're always encouraged to ask any questions, but I'm just saying why it's important to go through it now. Okay, let's stop talking. Let's go back to the lesson. So we've got a 1.3 times 100. 1.3 times 100. Now, first of all, what are these powers of 10? They're saying multiplying and dividing with the powers of 10, right? Powers of 10s are like 10 to the power 1. We're going to do a complete topic on powers, but just to understand this lesson, 10 to the power 2 means 10 times 10, which is 100. 10 to the power 3 means 10 times 10 times 10, which is 1,000. So do you see that the power tells us the number of zeros we're going to have. So the power is 1, we've got 1 0. The power is 2, we've got 2 zeros. The power is 3, we've got 1, 2, 3 zeros. When the power is 4, we would have 1, 2, 3, 4 zeros. That's that. So basically you're multiplying with 10, 100, 1,000, 10,000, so on. What happens is when you're multiplying, the decimal moves forward. And when you're dividing, the decimal moves backwards. I don't know if that's visible. Let's see. Okay. So when you're multiplying, the decimal moves forward. When you're dividing, the decimal moves backwards. That's the only thing we need to remember. So how many digits forward and how many digits backwards? Well, the number of zeros tell you how many digits forward or backwards. It's multiplication, so I'm going to move forward. How many digits? 1 and 2. So I've got 1.3. I'm supposed to move 1, 2 digits forward. So the decimal would end up coming over here, and I'd end up with 1, 3. I'll fill that up with a 0. 1, 3, 0. I can write a point 0. I can just write it at 130. Exactly the same thing. Let's take a look at another question on multiplication, the third one here. So I've got a 4 and it's multiplying, so I'm supposed to move forward. How many places? 1, 2, 3, 4 places forward. So it'd be 1, 2, 3, 4. The decimal ends up being over here. This space is over here is empty. So I would fill it in with a 0. So I've got a 0, 0, 0, 4's 0.0, which is the same thing as saying 40. So that's my answer. 40. I hope it's readable. 40. Now, when we're looking at division, remember what happened? The decimal moves backwards. How many places? 1, 2, 3. So it moves 3 places backwards. I've got 0.6. Moves backwards 1, 2, 3. Comes up over here. I fill them in with a 0. That just cancels out. So I've got a 0.0006. Next question, the decimal's moving backwards again. How many places? 2 places. So that's 39.11. 2 places, 1, 2. The decimal ends up coming over here. So I've got 0.1139. Done. Let's move on. Dividing decimals. Now, dividing decimals is not something I would encourage you to do the regular way because it gets too complicated and it's just not the GAT thing to be doing because GAT expects you to have a very breezy attitude towards this and this kind of thing is a bit intense. So what I would recommend you to do is to change them into fractions. We're going to go through them maybe two ways. Like if this question comes up, let's say, how would I go by it? Well, I could do 2 things. One of them is I would write it as 1.2 over 3.6. Isn't that what it is? Division's divided by, right? I can rewrite it like this as a fraction. What I could do is times it by a 10, times both the numerator and the denominator by 10. So this is a similar fraction that I'm looking at, right? It's a similar fraction because I multiplied both the numerator and the denominator by 10. So I would get 12 over 6. That's a 2, right? So when I'm multiplying by a 10, I move 1 decimal place forward. That gives me a 12. When I'm multiplying by a 10, 1 decimal place forward, that's a 6. So 12 divided by 6 gives me a 2. As easy as that. That's one way of going by it. Let's take a look at one more way of doing this. What I would do, another way of going by it is I would rewrite 1.2 as a decimal. Now, how do you write fractions as a decimal? Let's say I've got 1.2 and I want to rewrite it as a decimal. I ignore the rewrite it as a fraction. I ignore the decimal over, and what do? The decimal over here becomes a 1, and the number of digits that I have afterwards become zeros. So I only had 1 digit here, it would become 0. Let's say I had 1.23. That would then be 123 over, the decimal becomes a 1, and 2 zeros thereafter. We got an idea of how we're changing decimals to fractions? So we just rewrite the decimal the way it is without the decimal. Over, the decimal over here becomes a 1, and the number of digits you have after the decimal become 0. So 1.2 becomes 12 over 10, divided by 0.6 becomes 6. I get rid of the decimal. Over, what happens? The decimal becomes a 1, and I have 1 digit after that, 10. Now, I treat it like regular division of fractions, which is 12 over 10 times, flip over the second fraction, so it's 10 over 6. 10 and 10 cancel out. 12 over 6 is a 2. Whichever way you find easier. It would either be this one or this one. Whichever way you find easier, not a problem. But you must know how to change, for example, decimals to fractions. That's something we must know. Important. So I'll do it the same way. 100 and, okay, what I'm going to do is rewrite it as a fraction. 121 over, what happens? The decimal becomes a 1, then I add on 3 zeros. 1, 0, 0, 0. Divided by 1.1, I just write it as 1, 1. Ignore the decimal, that becomes a 1, and number of zeros thereafter. So I've got a brand new question, that looks like a fraction question, and here we know how to do fractions. So let's work it out. Fraction flips over, and I end up getting this. 0 goes off with the 0. And 11 times 11 is 121. Don't know if you know that already, but it's a square number. 11 square. 11 times 11 is 121. So 11 times 1 is 11, and that's 11 times 11 is 121. So I end up getting 11 over 100. That's what I end up getting. Now, there is a high chance that the final answer might be in decimals and not fractions. How would you then change the fraction to a decimal? Not difficult at all, because I've got the 11. If I rewrite it, it's like saying 11 divided by 100, right? So 11, because it's division, the decimal moves backwards. And when there is no decimal, we take the decimal to be in the end. For example, this is the same thing as saying 11.0, right? It's the same thing as saying 11.0. And what happens? The decimal moves backwards 2 spaces. 1, 2. So the decimal comes up over here. Probably not very clear. So instead of 11, I wrote 11.0 because I need to know where the decimal is. In any question, add all the decimals in after the number. If it's not given, it's after the number, after the number, after the number. So it's 11.0. Moving back 2 spaces, 1, 2. The final answer I end up getting is 110, and I add a 0 here. That's the same thing as saying 0.11. 0.11. So now we also know how to change decimals to fractions and fractions to decimals. That conversion is kind of important. We will go through it, go briefly through it in the next block when we're doing percentages. Anyhow, I hope you got an idea of that. Wow, let's start practice 1. Let's start the practices. So they're saying, in question number 1, they're saying, on a sunny morning, Umar rode his bicycle to a farm that sold baskets of pomegranates for 9.98 each and baskets of oranges for 9.98 each. Umar decided to buy a basket of pomegranate plus a basket of oranges. So he's buying pomegranates and he's buying oranges both. How much does Umar need to pay for his produce? How much does Umar need to pay for his produce? Okay, never mind. I don't know what that is. Okay. So basically he's buying 2 things. He's buying a basket of oranges and a basket of pomegranate, 9.98 and 9.97. Common sense, we've got to add them, right? How do we add decimals? Luckily over here, they are given in a row. I mean, even if you don't know that decimal has to be on top of the decimal, you'll manage, because it's not a problem in this question, but we do remember the decimal's got to be on the decimal, right? 9, 8, 9. 7 and 8, 15. 1 goes up here, that's 9, 8 and 1, that's 9 and 9, 18, 1 goes up here, 9 and 9 is 18, 1 more, 19. So it's $19.95 is how much he's having to buy these 2 buckets for. Okay, next question. Nadia walked to a gift store and after browsing for 33 minutes, decided to buy a souvenir for $5.11. So she's buying something that's $5.11. Nadia handed the salesperson $5.36. Oh, she's given a bit more than what she was expected. And for her purchase, how much change did Nadia receive? So she's given a total of $5.36, and she was only supposed to give 5.11. So we're subtracting, right? We're subtracting 5. Now, but the idea is this exercise is just checking that you know the decimals on top of this, basically getting you into the solving questions for decimal phase. Again, as usual, I encourage you to pause the video before I start doing the workout. So give it a try and then come back to the workout. So, you know, we have a better insight of where we're at. 6 take away 1, 5, 3 take away 1, 2, decimal follows the decimal, 5 take away 5, nothing. So she only gets 25 cent back, or $0.25 or 25 cents, whichever way. Okay, next question. Pause the video, because remember, when the teacher's solving, it's like, oh, this is so easy, so easy. To have a better understanding of where we are, we need to pause the video, attempt ourselves, come back to it, and double check. Okay, question number 3. Now, I'm looking at this question, and I do understand that I would solve them like this question here, or the question here, right? But remember, for the GAT, we're supposed to be like a bit more, we're supposed to work in a smart fashion, right? And remember, we said we would never do long additions and subtractions, so I'm trying to think of another way. If you take a look at this, it's 0.7 taken away from 9.7. Do you see? This is a negative here, and that's a positive. So it's a 9.7, and you're taking away from it. If I just rewrite it as 9.7, take away from it 0.7, would that be the same thing as what's stated here? 9.7 take away 0.7 is 9. 9.7 take away nothing.7, it gives you a 9. 0.7 is gone up. So I'll bring that back, that's a 9. Now 3.04 plus a 9, I'm only adding the whole numbers, which is a 12. 0.04 carries out. A bit quicker than doing the long addition subtraction, right? Question number 4. Now, one of the numbers I've got is a decimal, and the other number I've got is a fraction. Normally when questions like these come up, we're expected to change both of them into fractions, or both of them into decimals. So what I could do is, I prefer to change the decimals to fractions. So what I would do is rewrite that as, I can rewrite it as 2 over, the decimal becomes a 1, and that's a 0, 2 over 10. That's a division over here. I would change it to multiplication, flip over the fraction. Wow. Things are cancelling out. 5 times 1, 5 times 2. 2 times 1, 2 times 2. So I'm left over, 2 times 1, 2 times 1. Again. Sorry if this has confused you here. Let's take it. 2 over 10. Division becomes a multiplication, the fraction flips over. Yeah? Now, cancelling out, 5 times 1, 5, 5 times 2, 10. Next step, 2 times 1, 2, 2 times 1, 2. That leaves me with nothing but just a 1. That's the answer. Next question. Again, I've got a decimal and I've got a regular number. What I could do is just multiply 0.15 to 16, ignore the decimal, multiply the 16 with 125. I could do that, or, I mean, that doesn't look very easy to my mind because it's like huge, that this number is very big. I can't think of anything that would give me a shortcut. So what I would do is, I'll rewrite this as a decimal. 16 over 1, 0, 0, 0. So that's my new question. Very clearly, this and this is divisible by 5. One thing I'd like to tell you over here is that 125 times 8 is 1,000. You can jot that down somewhere because this is one of those numbers that come up a lot. This is one of those numbers that come up a lot in the GAT. 125 times 8 is 1,000. We are going to be going in depth when we're going to block the next block, block 3. So this number comes up a lot, which means over here, I could just simplify this. 125 times 1, 120, just so to make it easier for you, just let me rewrite it. So this thing is the same as saying 125 times 1, right? And that's from here, we know that this is the same thing as saying 125 times 8, right? So that 125 goes with this 125. And then next step, 16 and 8 are divisible. Let's go back to the same color. 8 times 1, 8. 8 times 2, 16. So I end up getting nothing but a 2. I've got a 2 here, and I've got a 1 left over here, and a 1 left over here. So that just leaves me with a 2. Okay? The next question, it's okay if you didn't get the hang of it. Maybe you can go back and go through this explanation again. Or if you take a look at the next question, it has the similar concept. Because if I try and multiply 48 by 125, that's like huge. I would not go down that path. What I would do instead is change, we write 48, change that into a fraction 125 over, how much? 1,000. So that's a 1000. And from here, we know that 125 times 1 is 125, and 125 times 8 is 1,000. 125 times 8 is 1,000, right? So I've got 1 over 8. And then 48 and 8 are divisible. 8 times 1 is 8. 8 times 6 is 48. That leaves me with a 6. As easy as that. So don't worry about this particular thing over here. Jot it down. It's something you need to remember. But the amount of questions that we're going to be doing, it would just stick in. Don't worry. Just jot it down somewhere. It's something important that we need to know. 125 times 8 is 1,000. Next question. Again, same thing. What I would do is convert it to fraction 100. That's 100. Divided by 66 over 100. That gives me the first fraction stays the same. Division changes that to multiplication. The fraction flips over. And so many things are cancelling out. 100 goes off with 100. 33 and 66, they come up in the table of 11. 11 times 3, 33. 11 times 6, 66. That leaves me with the 3 over 6. And then, can I simplify it a step further? Because 3 and 6, they both go in the table of 3. 3 times 1, 3. 3 times 2, 6. That leaves me with a half. So that's my answer, 1 over 2. Next question. They're asking us to compare the two values, 0.25 and 19 divided by 64, and tell is it greater than, less than, greater than, or equal to. Now, one of them's a decimal, the other one's a fraction. Yes, it is a fraction. It's 19 over 64, right? Can I just change that into a fraction as well to make things easy for me? Okay. Now, do we know the relationship between 25 and 100? It's times 4. Do we know this? If not, let's jot that down as well. Again, we'll be going through this in detail in the next block, but because it has come up, might as well take it down, because this is one of those combinations that come up a lot. So 25 times 4 gives me 100, which means if I simplify it, I could rewrite it as 1 over 4. 1 over 4 is the same thing as 0.25. But whereas if I look at the second option over here, it's 19 over 64. Now, we're not at the table of 19 yet, so what we could try and do is, can I try estimation? If I say, for example, let's say this is a 20, and let's say over the denominator is, let's say, roughly a 60. Why am I saying 60? Because I know times 3, 20 times 3 gives me a 60. So I'm saying, let's say that's a 60. 20 over a 60, that's 1/3. 20 over 60. 0 goes with the 0, times 1, times 3. 2 times 1, 2. 2 times 3, 6. That leaves me with a third. Which is greater, 1/3 or 1/4? Which is greater, 1/3 or 1/4? 1/3 is definitely bigger than a quarter. Divided into 4s, 1/4. Divided into 3s, 1/3. 1/3 is bigger than 1/4. So I hope you got the hang of it. Let's go on to the next question. They're saying x and y, the sum of x and y, or 0.67. Which one's greater? Well, x and y is given over here. We can try adding them up. So I've got a 60 over 100 plus 70 over 1,000. Am I allowed to add this? No, not really, because over here the denominator is 1,000, over here it's 100. What I could do is multiply them by 10 to make it 1,000. So now I have 600 over 100 times 10 is 1,000. Now I'm allowed to add them up. 1, 2, 3. That gives me 670 over 1,000, right? Which is the same thing as saying, because that's a decimal. This number over here is a decimal, so I need to convert it back into a decimal. That's the same thing as saying 670, this one here, 670 divided by 1,000. When it's division, we move backwards. How many spaces? 1, 2, 3. So it's a 670. The decimal's over here. 1, 2, 3. The decimal ends up coming over here. 0.67. 0. Let's add up the 0. Is this the same thing as this here? The 0 in the end doesn't make any difference. So that means they're both equal to each other. Next question. 10. That's funny. 1 over 1. That's just a 1. Times. Actually, you can just ignore that altogether because 1 times anything is 1 itself. So I'm just going to ignore this. Now, this is a very strange way of writing something because it's like a fraction, but then in it you've got a decimal. So I would prefer to change everything into a fraction. So I would say 1 over 0.24 can be rewritten as 24 over 100. That is what I would inject back into the equation, into the expression. It's 24 over 100 times 1 over 3. Have we seen something like this before, and do we know how to deal with it? I think so. We did something like this previous lesson. 1 over a quarter is a 4. The denominator of the denominator actually goes to the numerator. Last lesson, right? So that means 3 is going back in the numerator, and 100 over here, the denominator of the denominator is also going back in the numerator. So I've got 100 over 24 times just a 3 over here, because 1's are nothing. 1 times anything, something divided by 1, same thing. And now I can simplify 3 times 1, 3, 3 times 8, 24, right? And then, can I simplify this a bit more? Because usually they require answers very simplified. I'll divide them by 2, because both of them are even numbers. So 100 divided by 2, 50, and 8 divided by 2, 4. Can I divide them again? I think so. Both of them are even numbers. I can, again, divide them into 2. 50 divided by 2, 25. 4 divided by 2, 2. That's it. Can't simplify anymore, so that would be my answer. 25 over a 2. Next question. Oh, so there are, okay, we're done with the practice. Practice 1, we're looking into table check. Things are getting a bit serious now because we're already into table 6 and we should be ahead of the game. This is our second last day for block 2. Block 3 is going to be a bit more challenging than block 2 naturally as it goes in any learning curve, which means we should be okay with the tables. Last calling. Tables 2, 3, 4, 5, 6, 7 for this block. Concrete them and only then move on to the next block. Let's go. So are we racing now? You're allowed to count on, no problem, because it's the table of 6. Let's race against each other. Let's start now. 6 times 1, 6. 6 times 2, 12. 3, 18. 4, 24. 5, 30. 6 times 6, 36. 7, 42. 6 times 8, 50. Oh my god, no, 48. 48, 48. 48. 6 times 9, 54. 6 times 6, 60. 6 times, what am I saying? 6 times 10, 60. 6 times 11, 66. 6 times 12, 72. 6 times 13, 78. 6 times 14, 84. 6 times 15 is a 90. 6 times 16, 96. 6 times 17, 102. 6 times 18, 108. 6 times 19, 114. 6 times 20, 120. Done. So I hope I haven't done any mistakes. If I got any, catch me out and post it underneath in the discussion forum. Okay, I hope we're done. Table check. I hope you finished it before me. Let's go on to the next thing. What do we have next? I think the table. Okay, we're into the guided practice now. Pause the video, try and attempt the questions. We've got a total of 20 questions. Attempt them yourself, and then you should come and check this back. Let's start. Question number 1. Very easy, because I'm going to ignore the decimals. That's 1 times 1, that's a 1. Counting decimal places, 1 and 2. So I go back to places 1 and 2, put the decimal, fill it in with the zeros. That's 0.01. Option B. Next question. Not so easy. This question is not very easy. This question is, there are 2 ways of going by it. You could either estimate, or you could work specifically. Let's go by estimation first, and then we go out the specific workout. This thing, do we see that it's almost like a 1? Especially if I it's a bit less than a 1, very slightly less than a 1. And do you see how small this number is? Do you see how small this number is? It's not even a 0.1, like a 0.0 or something, yeah? So what I would estimate is that these 2 would give me something equivalent, would give me a 1. These two would give me a 1, because that's like something divided into 4, that's 8, and 1 more time. Oh my god, no. Let's pick something else. Let's say I've got this. That's 4, that's 16. So like everything's shaded, they're talking about this small piece. This over here, I'm giving out the answer. This thing, whatever it is, let's say, this here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's this one over here. So do you see how small this portion is that's missing? So that's like almost a 1. And this is so minute that I would say that they both add up to give me a 1. Remember, I'm estimating, right? They both add up to give me a 1. Let's take a look at the other thing. This looks a bit familiar to me. Because if I change it into 125 over 100,000, that's what happens when you change it into a fraction, right? So 125 over 1,000, we've seen this before, right? Remember this? So I can simplify it. That's times 1, and that's times 8. 125 times 1, 125. 125 times 8 is this. That's the same thing as 1 over 8. Do you see how this is a 1? That's 0.125 is 1 over 8. When you add them 2 together, that gives you a 1. 8 plus 1 over 8 is an 8 over 8, which is a 1, right? So we've got a 1 here, and we've got a 1 here. That gives me the option 2. Part B, 2. Now, if you want to work it out, let's go to the next question and work it out, because it's a similar question to this one here. It's a very similar question, so we try working it out. We use help in the other one, we use help with estimation. When you're sitting for the JAT exam, do not hesitate to estimate, because you wouldn't have the time and the mental ability, that time under pressure, to be working out every single thing. They're expecting you to estimate and use your instincts and be a bit smart about it. But otherwise, just to know the procedure, let's take a look at this. This is 15 over 16 plus, I want to rewrite that as a fraction, so that's 1, 2, 3, 4, 1, 2, 3, 4, plus 7 over 8 plus 2 over 8. That's a 1, right? Isn't it? 7 over 8 plus 2, no, that's not a 1, that's a 9 over. My bad. Okay, and then let's take a look at the last portion here. Can I rewrite it? 125 over 1,000, right? And can I simplify it to get what? 125 times 1, 125. 125 times 8 is 1,000. Remember, this is something we needed to know? That's what I've used. Times 8 is 1,000. So this is the piece of information that I used to get this here, 1 over 8. Done? Now that I've got everything in fractions, what I'm going to try and do is start to add them up. 7, 2, and 1, that's 10. 10 over 8. And luckily all the denominators are the same, so I can just add them up. 10 over 8. How about this portion over here on the left-hand side? Now, that I can't do anything to that one there, so that's 15 over 16. How about the middle part? This is the one that I'm trying to work on. Let's say 625 and this. Are they divisible in the table of 5? It's divisible in the table of 5 because 15 square. So if I divide that by 5, that would give me 125. We're going to be learning powers as well in the topic of powers. 5 to the power 1, 5. 5 squared, 25. 5 cubed, 125. 5 to the power 4 is 625. 5 to the power 4 is 625. So that means I know this is like 5 times 5 times 5 times 5. We're going to be learning this when we go to the topic powers and radicals. This is the information we're going to learn. So I know 5 to the power 4 is 5 times 5 times 5 times 5 is 625. That's what I'm going to make use of. So 5 times 1, 5. 5 times 2, 10. The zeros carry on. 5 times 1, 5. 5 times 4, 20. The zeros carry on. 5 times 1, 5. 5 times 8, 40. The 0 carries on. 5 times 1, 5. 5 times 16 is 18. So that's a 1 over 16. 1 is what's left. 1 times 1 times 1 times 1 over a 16. So that's 15 over 15 plus, so when I add them both together, I get 16 over 16 plus 10 over 8. Should I make both the denominators the same to be able to add? I'll multiply this by 2, I'll multiply this by 2. That gives me 16 over 16 plus 20 over 16. That's 1636. 16 over 36. Shall I simplify? Because very clearly they're both going in the table of 4, right? 36 divided by 4, 9. 36 divided by 4, 9. 16 divided by 4, 4. So that's my final answer. Anyhow, again, I mean, it's good to know how we worked it through if we go through each and every step, but it would be very silly to be sitting in the GAT and doing this entire workout. You'd want to go with the estimation. Or if I was you, like, what I would do is just, it's such a small value, I would just ignore it. What I would say is like, okay, this looks like almost a 1. And because that is such an important thing, let's say set of number that comes up so much, 155 times 8 is 1,000. I know that's 1 over 8. I mean, that thing we need to know. And that plus the 7 over 8 is a 1. So I would know, okay, that's almost a 1, and a bit more. So let's go back to the options. So I have 2, I have 1, and 2, and I have a bit more here. So I would say, okay, definitely more than 1. I'm looking at the options now, A, B, C, D. Definitely more than 1. 1 over 16 is too tiny. 2 over 9 is very tiny. This is the only one that looks appropriate. 9 divided by 4. This is more than 2. So this is the only one that looks appropriate. So I go by estimation. Anyhow, that drains my mind. Okay. Next question. Question number 4. Let's clear out our minds. I think it's a bit drained now. Pause the video, go and sip some water, and then let's restart. Now, question number 4, they're saying compare these two things. I've got 0.75 times 88 divided by 3. Very clearly, this is something I have already. This is the area that I need to start working on. 0.75 is 75 over 100. And now that we've done the table of 5, we know that 75 divided by 5 is 15. So 5 times 15 gives me a 75, and 5 times 20 gives me 100. 5 times 3 gives me a 15. 5 times 4 gives me a 20. So 0.75, I would rewrite it as 3 over 4 times, I have the 88, 8, divided by, I would just write it like this, divided by 3. So this is what I ended up with. This is what I have now. 3 goes off with the 3. Let's simplify each other. 4 times 1, 4. 4 times, I know 4 times 20 is 80. So 4 times 21 would be 84. 4 times 22 would be 88. That's 22. If difficult, like simplify it with 2 first. Let's say you have this. So you divide them both by 2. 88 divided by 2, 44. 4 divided by 2, 2. Then, again, you divide by 2. That gives you a 1. 44 divided by 2 is a 22. So that's your answer. This entire thing equals 22. That's greater. Very clearly, 30 is much bigger. Next question. Question number 5. We're comparing 3 over 5. 3 over 5. Comparing 3 over 5 to 0.3 over 0.3 over 5 times x. I know that the value of x is 10. I know that this is 10, so let me just rewrite it as 10, 1, 0. 0.3, I'm looking at the numerator. 0.3 times 10. The decimal moves forward 1 place, right? That's just a 3. So that's equivalent to 3, and in the denominator I've got a 5. That means they're both equal to each other. Next question. Question number 6. A 1 whole, or a 1 whole divided into 1.2. 1.2 is bigger than one whole, isn't it? On the number line, if this is where your 0 is, this is 1.2, 1 would be somewhere over here, 1.2. So a small number divided by a big number. One small number divided by a big number, definitely that's going to be lesser than a 1. That would be something lesser than a 1. And that's a whole, that means this is greater. 1 is greater. Yeah, next question. Next question, we're doing 0.03% of, I know we haven't done percentage before, but based on the information about percentages that we have already, anything percent, 5% means 5 over 100. We'll be covering this in detail next lesson, inshallah. So 5% is 5 over 100, 20% is 20 over 100. So basically when you see this percentage sign, that means divided by 100, which is the exact same thing we would apply over here too. So I've got 0.03%, that means 0.03 divided by 100. What happens? Division, so the decimal moves backwards. How many places? 2 places. So let me rewrite it. That would be, it's moving back 2 places. 1, 2, goes over here. So I have a 0.00, or we can even write it like this actually. I'm checking which way would be easier. Let's just go with this. Okay, so I have a 0.0003. That's this over here, 0.03%, so you're moving back 2 more spaces. Off, remember, off in mathematics is, times. And off in mathematics is times, correct. So times, this is the exact same thing as the one before. I would just rewrite it, 0.0003. Off, again, is multiplication, 1,000. 1,000, let me apply the 1,000 to this number. Like, let me work with these two to make things look a bit simpler. Multiplication means the decimal's moving forward. How many places? 1, 2, 3. So we're moving forward 1, 2, 3 places. The new decimal falls over here. I've got 0.3. All the zeros in the beginning don't make any sense, so I wouldn't write them down. 0.3, the other one, I just copy it down. Finally, I have something I can work with. 3 times 3. Remember we said we just ignore the decimals? 3 times 3 is a 9. And how many decimal places am I moving? 1, 2, 3, 4, 5. So I'm moving back 5 decimal places. 1, 2, 3, 4, 5. 0. Fill them in. All the places. Be careful. You might overlap one with the other. Which option is that? I've got 1, 2, 3, 4 zeros. Looks like this one. I've got 1, 2, 3, 4 zeros. It's option B. Done. Let's move on to the next question. This is, and by the way, this question is from the booklet that the Qiyas gives out for the GAT preparation. So, I don't know how important it is, but they have it in the booklet. No one's ever reported of it coming up, but because it's in the booklet, we're going to go through it. Next question, question number 8. Give it a try, because it's something I'm sure you would know. 108 divided by 100. Division means the decimal, which is over here, is moving backwards 2 places, 1, 2. So I've got a 1.08 plus. Same thing here, moving back 1, 2, 3 places, 1, 2, 3, right? So I've got a 1.008. Moving back 1, 2, 3, 4 places, 1, 2, 3, 4. 1.0008. Now, looking at the whole numbers, I've got 3 whole numbers, then I've got the decimal. Then I've got a 0, 0, 0. Then I've got 8, 0, 0, that's an 8. I've got nothing here, so I'm done with it. The next I've got 8 and 0. So that's an 8, and eventually I just have an 8 left over here. Oh, why do I have a plus here? 8. 0.0888, 3.0888. Looks right. That would be the solution. I don't know how easy you would find this. I mean, this is what we're doing. 1.008. Remember lining them up? 0008. So when I added them up, I got an 8, 8, 8, 0.1. 1, 2, 3, 3, 3, 3. That's a 3. So I hope this was an easy question. The answer is part option C. Let's take a look at the next one, question number 9. How would we go by this? It's a decimal divided by a decimal. I could rewrite them as fractions. I think that would be the easiest way of going by 1 over 1, 2, 3. 1, 2, 3. Yeah. Divided by, again, 1 over 1, 1, 2, 3, 4. 2, 3, 4. 4 zeros plus, so I should be working on this first. Changing that to decimal again, to fraction again, 1 over a 10 divided by 1 over 1, 2, 3, 4. 10,000. 10,000. 1, 2, 3, 4. What do I do now? I've got 1 over 1,000, change the sign to multiplication, flip over the fraction, over 1, do the exact same thing on the other side as well, flip over the fraction, over 1. Deal with these first because of the multiplication sign. The 0 goes with the 0, one of them's in the denominator, the other's in the numerator, so we're allowed to cancel out because we're cancelling out over a multiplication sign. If it was an addition, we wouldn't have. That leaves me with a 10 only. Plus, what's happening here? The 0 goes with the 0, I'm left with 1,000. So that's 1,010? 1,010, which one is it? A. Option A, 1,010. Let's take a look at the next question. Now the question's in fraction and the answer that they're expecting in decimals, which means, that means I want to get rid of the denominators, right? 0 goes with the 0, I'm left with a 90, plus 0 goes with the 0, that means my decimal's over here, and I'm going to go back 1, 2 decimal places, 1, 2 decimal places, that's what I would get. 0 point, fill it in, 0, 9, plus, where's the decimal? Right at the end. I'm supposed to move back 1, 2, 3 decimal places, 1, 2, 3, fill them in, that's 0.009, so I've got a 90.099. This option over here. If you want to add, you can always write them. If you think it's a bit confusing for you to begin with, you can always write them like this and then add up till you get used to it, and you can do it mentally in your mind because that's what we're targeting at finally in the end. Let's take a look at the next question. Question number 11. 1 over 2. 0.5. I mean, again, a weird situation because I've got a decimal and I'm looking to change that into a fraction. 5 over 10, right? 0.5 is 5 over 10, so I'd rewrite it as 1 over 5 over 10 times 1 over 5 over 10. Remember, the denominator of the denominator goes back into the numerator. So a half stays the way it is. The 10 goes back up. So I have a 10 over 2 times, same thing. The denominator of the denominator becomes the numerator. Oh, why did I write 2? That's a 5. 10 over 5, 10 over 5. 5 times 1, 5. 5 times 2, 10. 5 times 1, 5. 5 times 2, 10. 2 times 1, 2. 2 times 1, 2. I'm left with only a 2. So the solution is 2. That's that. Up until question number 11. We're going to question number 12 now. Question number 12 here. Oh, they look so familiar, don't they? 125 over 1,000, isn't it? Plus 125 over 1,000. 125 over 1,000. And they look so familiar because we know 125 times 8 is 1,000. So 125 times 1, 125 times 8 is 1,000. The same thing carries on. So I have a 1 over 8, 1 over 8 plus 1 over 8 plus 1 over 8, right? And I have 3 1 over 8 over here as well. So basically I'm adding these two together. Adding them together. That's a 6 over 8. The denominator is all the same. So 1, 2, 3, 4, 5, 6. 6 over 8. That's not in the options unless I simplify it to be 3 over 4. Divide this by 2, and the answer is option A. Next question, number 13. Number 13, how would I go by this? I think the easiest way would be to get rid of the denominators. I'm going to do it a different way. I'm going to get rid of the denominators because 1, 2, 3, that means if I multiply by 1,000 and multiply by 1,000, I would have 1, 2, 3, so the decimal comes here, right? So I have a 1, fill it in, so I've got a 100 over 1,000. Oh, no, 100 over a 1. 100, the numerator is 100 over 1. So that's why I'm multiplying with 1,000 because I want the decimal to come here and just end up with a 1 in the denominator. Next question, next part, what should I multiply it with? I want 1, 2, 3, 4. So I want to multiply it by 1, 2, 3, 4, 10,000. So I'll multiply both numerator and denominator by 10,000. That means I'm moving forward 4 places. When I move forward 1, 2, 3, 4 places, I get just a 1 in the denominator. In the numerator, 1, 2, 3, 4. So the decimal comes here, fill it in. That's 100. 100, right? What should I multiply with over here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, 0. Again, that's 100. Wow, so I have a 300 over a 1, which is the same thing as 300. 13. The option's B. Next question, question number 14. How should I go by this? I've got fractions and I've got decimals, but the answer is in a fraction. What should I do? Well, let's work in fractions. Let's change that into a regular fraction. 3 times 4, 12. 12 plus 1, 13. 13 over 4 minus 11 over 2. Plus, what do I do to this one over here? 0.75. I do recognize that. So that means this is 1 whole. And 75 over 100? Could I say that? Because this is a whole number, so I write that down over here. 0.75 is the same thing as writing 75 over 100. So 1.75, I could very easily rewrite it as this over here. But using 75 and 100 is not very sensible because they're big numbers, unless I simplify them. That's 15 over 20, that's 3 over 4. 0.75 is 3 over 4. By the way, this is also one of the special numbers. We will do them in detail next block, inshallah. 0.75 is equivalent to 3 over 4. It's a number that comes up a lot. It did come up in today's lesson. It's coming up the second time, right? It comes up a lot. So it's something you can know as well. So what I have is a 1 whole 3 over 4. That's 4 times 1, 4. 4 times 1, 4, plus 3 is 7 over 4. 7 over 4. I'll add these two together, and then later on look at the 11 over 2. Add them two together, 13 and 7, that's 20 over 4, right? And to be able to subtract 11 over 2, I'll multiply them by 2. I'll multiply both by 2, so I have a 20 over 4. Take away 22 over 4. Denominators are both the same. I have a negative 2 over 4, which is a negative 1 by 2. Simplified, negative 1 over 2. That's the answer. Part D. Next question. The question's in fractions, the answer's in decimals. I'll change them into decimals. That's a 0.7, so I'm saying 7 divided by 10. So the decimal is here. When you divide by 10, you move back one space, so it comes over here. You have a 0.7 plus, how many spaces are we moving back? 2 spaces here. 1, 2. Again, 0.7. 0.7 plus 0.7 is a 14, but I move back 2 decimal places, right? I move back one, no, okay, again. 0.7 plus 0.7 is 1.4. 7 and 7, 14. 1 goes up here, 1.4. That's the answer. B. Next, question number 16. This is the exact same as this one here, 16. 11 over 2, 3.5. Looks like we've done it before. It's something similar to question number 14. So I've got 6 points instead of the. How would I work with this? Shall I change it to decimal or shall I change it to a fraction? So the answer is in decimal. I want to change it into a decimal. The answer is in decimals, right? So 6 1 over 4. That's a quarter. So that means, can I say 6.25? Right? And from this, Zara is left with 6.14, so that's the total amount of money she has. From this, she gives 11 over 2. How much is 11 over 2? 11 split into 2 is 5.5. So she gives away 5.5. That's 5.5. And Ali gives her 3.5 back, so he's giving her back. That means adding 3.5 into it. Okay, so that's done. A quarter is 0.25, so which is why I wrote 6.25 over here. 11 divided into 2. 11 sandwiches splitting between you and your friend. 5 you get 5, she gets 5, and the last one splits into 2, which is why we rewrote it as 5.5. Now, how do we add and subtract? This is a negative 5.2 plus negative 5.5 plus 3.5. How much? Sign off the bigger number, and I subtract them both because of the opposite signs. That's just a 2. 3.5, 5.5. There's 2 in between. 6.25, take away 2 is 4.25. Option B. I hope it's clear. It's going past an hour today. No problem. Inshallah, take a break and come back maybe. It's just like 4 more questions, 17, 18, 19, 20, 4 more questions, and word capital. That's it. Denominator of the denominator go to the numerator, so it's 4x equals denominator of the denominator go to the numerator, so it's 5 times 5, 25. Yeah? Now, x is 25 split into 4. That's what x is. But hey, the answer is in decimals, and we're getting a fraction. What should we do? You can either do it mentally. For example, I do know 4 times 6 is 24. I know 4 times 6 is 24. So if I'm trying to split, let's say, 25 apples into 4 girls, each would get 6, and there would be 1 left over. Each would get 6. So I have a 6, 6, 6, and 6. That's a 24, but actually I have a 25. That means there's 1 left over. There's 1 more to go. 6, 6, 6, and 6, and then they each get a quarter, which is 0.25, 0.25, 0.25, 0.25, which is each one gets 6 and a quarter. So that's 6.25. Yeah? Next question, question number 18. Which is greater? Denominator of the denominator goes into the numerator. Denominator of the denominator goes into the numerator. That means I have a 0.0011 and 0.22. Which is greater? Definitely this one here, because the 10th place is 2 and this is a 0, so that's greater. Next question number 19. Which is greater? Now remember we said like half or 1/3. As the denominator gets bigger and bigger, the fractions are actually getting smaller, right? So over here, which denominator is bigger? 0.224 or 0.223? That is greater. Which means, because it's a bigger denominator, like this one here, that means it's the smaller denominator that's bigger in fractions. Just like 1 over 2, 2 is smaller, so half is bigger than 1/3. Next question, which is greater than 3.331? That means we've got 3 holes. Do you see that the options are in fractions? So I'm going to try and convert them into the same thing. I've got 3 holes here, and then this portion, I'll just change it into fraction. Can I say it's 331 over 1,000? Because that is 1, 2, 3. That's the number we have over here. They're saying which is greater. Now that looks exactly the same as this one here. There are no whole numbers. There are no whole numbers, which means they're way smaller than what we have over here. And over here, I've got a 3 hole and 333. That's 331. This is 333, which means this is greater. That's it. We're done with most of it. Just the last bit left. We're looking into vocab building. 3 new words for today: capital, bruise, and war. I think you've heard them before. You might even know a meaning or two, but each one of them has more than a meaning, which is why I thought it's a good thing to be looking at. And another point that I want to make about the new words, so I bring you 3 words and you get the other 2, right? So the other 2 that we're looking into are words of every day. Don't pick on very fancy looking words. Words that we use every day, but something that you never bother to go and look at the meaning for. So those are the kind of very normal, not hi-fi words that we're looking for. Capital. So if I look at capital, I know that capital is, for example, you have a capital of a country, right? A capital of a country, so that's one meaning that capital has. So something of prime importance. The reason a particular place has a capital, for example, Riyadh is the capital of Saudi Arabia, because all the embassies are over here. Majority of the decision taking happens in the capital, which is why it's referred to as capital, because it's of prime importance because of the dealings that are happening over here. Because you could also use capital. You can also say, oh wow, that's a capital idea. That's a capital idea. I mean, or like I started a business and it was his capital idea. So basically something that is very important. So that's that. And then you also have capital letters, right? Capital letters. Like you have a small a and a capital A, small b and a capital B, that capital letter. So that's also something that means capital. Or if you've noticed, like these people who are really famous and rich, it's like, oh, what's her capital? What's his capital? That means what they're looking into is how much is their net worth. If you've heard this before, net worth. Net worth is something called, it's also referred to as capital. So for example, I'll say her net worth is $2 billion because like she has this amount in her bank account and she has 4 properties and etc. etc. So that's also where we use wealth and money. Property owned by a person or business is also something we say is a capital. Wealth, money owned by a person, or it could also be owned by a company, or a business or something. So we've got three different meanings of the word capital. Let's take a look at the next one, bruise. We know that already. Bruise means is usually, when I say, for example, I go like, if I fall down, I get a bruise. Bruise is that yellowy, purplish kind of patch that you get that it hurts when you press on it. That's what bruise is. Basically, the blood vessels sort of burst, and there's like a blood leakage inside underneath the skin. That's what is referred to as bruise. But it's not just humans that can get bruised. For example, even an apple can get bruised. So if the apple fell on the ground and it's going purply on a side of it, that means it's bruised. People, for example, someone bruises really easy. They'd say, oh, I bruise so easy, like a peach, because peach bruises very easy. It's a soft fruit. So we'd say it's like we'd say dark, painful area, dark, painful area on the skin. I bruise like a peach. That would be saying I bruise so easy. One more meaning that bruise has is to hurt someone's feelings or confidence. Or it could also be something on fruit, but obviously if it's on the fruit, it wouldn't be painful, but like a dark spot or something. A damaged fruit, let's say. Bruise, you could also say, oh, he lost the race, that bruised him. Losing the race bruised him really bad. So bruise can also be used in a figurative sense, where you're hurt, your feelings are hurt, your ego is hurt, that kind of a thing. To hurt someone's feelings, let's say. To hurt someone's feelings, his ego was badly bruised when he lost the race. Bore is the third word that we're looking into. Bore has a very common meaning, like, oh, I'm so bored. It's the same bore. It has more meaning, so it comes from there. It's the past tense of being bored. When you say bore, what do you mean? When you say I'm bored, what does that mean? Could you put that down in words? Well, it means something being so uninteresting, and to the extent that it starts to annoy you, it starts to get to you. So that's what boredom is. Something uninteresting. Something uninteresting to the extent of getting annoying, let's say. Getting annoying. That's one meaning of boredom or getting bored. Then there's another meaning of getting bored is to, for example, the teacher's eyes bored into me. The teacher's eyes bored into me, which means something piercing through. This is a figurative way of saying it, but you can also say if you, for example, making a hole into something. Making a hole, especially with a pointed tool. So making a hole with a pointed tool, if you're using it, the carpenter bored holes into the wall. If you're using it for the second meaning. Let's take a look at there's another meaning for it. There's one more meaning for it, like let's say a tidal bore. It's like a giant wave that rushes into the river. A giant wave, the river moves, right? The water moves in the river. So when a giant wave comes up, we say it's a tidal bore. A giant wave that rushes into the river. That's that, guys. We're done for today, and I'll catch you tomorrow. The lesson's overdue already, like past a lot of minutes gone by. I'll catch you tomorrow, and we'll be doing a review on everything that we've done so far. So wrapping up the second blog, and preparing